Happy Wednesday, everybody! Today we are going to learn about the average rate of change, and it's only fitting that we began our year learning about rate of change with linear functions, that we would be concluding our year with a discussion about change, because the only thing constant in life is change, and a large part of math is about how we can measure change. So let's start with what we already know about rates of change. We learned at the beginning of the year that a constant rate of change is seen in the linear function, and that we have our slope formula, which is m equals y2 minus y1 divided by x2 minus x1, and that's what tells us the rate of change for this particular linear function or the line. So if we simply label our points here, x1 and y1 down here, and x2 and y2 up here, we take y2, which is 5, minus y1, which is 0, and then we divide all of that by x2, which is 0, minus 2, which is x1. So that gives me 5 over a negative 2. So that means my rate of change here is a negative 2.5. Okay? And that would make sense because it is a decreasing line and a negative sloping line. All right, so that's what we already know. Now, if I look here at the next function that I learned, which is the exponential function, okay, we can find a rate of change for an exponential function. But because it is not a linear function, it's going to be what we call an average rate of change. So to find the average rate of change, it's two steps. The first thing we're going to do is draw what we call a secant line. So a secant line is a line between these 2 points that we are trying to find the rate of change between. So that is the secant line. And then the next thing that we are going to do is find the slope of that secant line. So I'm going to use my slope formula, which is m equals y2 minus y1 over x2 minus x1. So again, if I simply label my points, here's x1, y1, x2, and y2. I take my y2, which is going to be 54, subtract y1, which is 6, divide all of that by x2, which is 3, minus x1, which is 1. So 54 minus 6 is going to be 48. And then 3 minus 1 is 2, so 48 divided by 2 is 24, which means my average rate of change between these 2 points of the exponential function is going to be 24. Okay, so if I move on to my next example, the next function we learned was the quadratic function. And same thing, we can find an average rate of change for our quadratic function. So if I identify 2 points, I'll pick my minimum point here, and I'll pick another point on the curve right up here. And I'll label this one. So my ordered pair here is negative 3, negative 2. So that's going to be x1 and y1. And then up here, I have an ordered pair of negative 1 and positive 2. So that's going to be my x2 and my y2. So same thing, I use my slope formula because between these 2 points, I can do what we call draw the secant line, which is right there. So that's going to be m equals y2 minus y1 divided by x2 minus x1. All right, so y2 is going to be 2 minus y1, which is a negative 2. And then all that's going to be divided by x2, which is negative 1, minus the negative 3. All right, so we know that 2 negatives make a positive, so that becomes 2 plus 2, which is going to be 4. And then negative 1, these 2 negatives make a positive, so negative 1 plus 3 becomes a positive 2. So here my slope is 2. So that means my average rate of change for this function is going to be 2. All right. So let's look at one word problem and summarize what we've learned. So what we've learned is if the graph of a function is not a straight line, which is what we've looked at with our exponential function, which is a curve, and our quadratic function, which is a parabola. If it's not a straight line, the average rate of change between any 2 points is the slope of a line containing the 2 points called the secant line. Okay, so if we look at this last example here, I have an example of the growth pattern of a young boy up through manhood. And we're looking specifically, age is on my x-axis and the height is on my y-axis. So I'm specifically looking at a relationship of age to height. So my starting point down here, which would be my x1 and y1, and then my starting point, my end point up here would be my x2 and my y2. So we're comparing him between ages 13 and 18. So if I start with 76 is my y2, and I subtract 57, which is my y1, and then divide all that by my x2, which is 18, minus 13. That leaves me with 19 divided by 5. So if I divide 19 by 5, I get 3.8. So what that tells me is that the boy grew an average, his average rate of change between ages 13 and 18 was 3.8 inches. All right, so for your exercises today, I have some average rate of change problems that you can do. All right, there's 3 of them. So here's a graph and then a few questions about the graph. Go to the next page, a graph, a few questions about the graph, and then the final page, a graph and 2 questions about the graph. All right, so if you have any questions, contact me through Google Classroom or come and see me on Google Meet. Have a great day, everybody.